Now that we know about how the database file is stored in the disk and why is the need of indexing, let's talk about how do we create indexing and of a how do we create an indexing of a database file. So there are three mechanisms or three ways we can create an index. There are three types of indexing of DBMS. First is known as a primary indexing, then we have the clustering indexing, and then we have the secondary indexing. So let's first talk about how primary indexing works. So what happens in the primary indexing? So let's suppose कि this was our data and there were five blocks needed to store our table B1, B2, B3, B4 and B5. So these were the 5 blocks needed. So primary indexing works on the key field of the your table. So here what is key field? This roll number is the key field. So your primary indexing works on the key field. We create an index on this field roll number, and so to create a primary index of the table, your data should be sorted according to the key field. So as you can see, my table is sorted according to the roll number. So now we can use the primary indexing and create a index on this key field roll number. So in primary indexing, your index file stores two things. First, it will store the key roll number and it will store the block pointer of that roll key field. Okay, so it stores two things. First, roll number, and second, block pointer where that roll number is stored. So, and how this stores this key will create one index for each disk block. So roll number 1, right, this is stored at the block B1. Now we know that key, as you can see यहाँ पे roll number 1 is stored in B, and the primary indexing each record or we create an index for each disk block. Now since for B1 we have created, we'll create for B2. So B2 starts storing the data from roll number 3. So we can store the B2 here. Now roll number 5 are stored in B3. Roll number 7 is stored in B4. And roll number 9 is stored in B5. So this is the index file for this table using primary indexing. Now how does it help us reduce the number of disk block accesses? So let's suppose we want to again find the database of or record with roll number 8. So what we'll do, we'll first access the index. Now this index itself must be stored in the hard disk somewhere. So let's suppose for now this entire index is stored in one disk block. Okay, so this is stored in one disk block. So first we'll access this index and check where this 8 is stored or the disk block number of this record 8. And how will we check this? As you can see, from here we know that key record 7 starts from B4 and record 9 starts from B5. So from this, by checking these two fields, I can say that key record 8 is stored in the block B4, because from B5 onward, B5 stores 9 and B4 starts from 7. So it will be either in B4 or B, right? When we check this, we know that key either your 8 will be either in B4 or B5. But by checking key this field, we know that key B5 starts from 9. So roll number 8 should be stored in B4, and from there we can know key we need to check B4 to find our data. So how many disk blocks access are needed? One, to access this index block and check where the actual data is stored. Second, this to retrieve the actual data. So 2 disk block access are needed. Access are needed here, which is very low compared to what was needed before, right? Before we had to do key first we need to check B1, then B2, then B3, and then B4, and in worst case B5. So without indexing we needed to check each and every disk block, but indexing help us narrow down our search and look for the block which stores the data. So this index, the primary index, so to summarize, primary indexing works on the key field, and one index records stores roll number and block pointer from where that roll number starts. And based on these two information, I can narrow down my search and find where particularly one roll number is stored. As you can see here, we are creating index for one block, right? This row represents the block 1, this one represents the block 2, this one is the index of block 3, this one is index of block 4, and this is the index of block 5. So we are creating index for each block in primary indexing. So because we are creating the index for each block instead of each record, this indexing type is known as a sparse indexing, because we have created index for only a selected rows instead of each row. Okay, this is primary indexing. Now let's talk about the second indexing mechanism called clustering indexing. So how does clustering indexing works? So in the primary indexing it was working on the key field. So clustering indexing works on the non-key field of the data. So clustering, the first thing, clustering indexing works on the non-key field. One more thing, in your data should be ordered according to non-key field. So as you can see, this data is ordered in respect to non-key field. So how do we, so data must be, data and in must be ordered according to non-key field. Okay, so again there are 5 blocks needed: B1, B2, B3, B4, B5, and this data is sorted according to the non-key field, as you can see. Now, how do we create a clustering index? So what happens? Clustering index is created for each unique value in non-key field. So we'll create a cluster or an index for each unique value. So how many unique values are there in this field or in this table? As you can see, this is one value, this is one value, this is another, this is another, this is one, and this. So there are 7 unique values out of 10. So we'll create one index record for each of these fields. So in the clustering indexing, index file or contains two things. First, the non-key value, non-key field value, and second is block pointer from where this non-key field is started. Okay, so how it will be created for this example? So first we'll create for this arrow, so and where this arrow is stored, like from where this arrow, the data or information about arrow is being stored is B1, so we'll store B1. Second, Aditi, and for Aditi we'll store ki from where this Aditi, the information about Aditi is stored in the DBMS. So it started from B1 and went to B2. So we'll store the first B1. Why? Because from there we can know ki information about name Aditi is stored from B1, and from there all the contiguous we need to check until we find another name. So to search for Aditi, information regarding Aditi, we'll start our search from B1 and go to the B2 also, because B1 doesn't end with new information, and here we find a new name. That's where we know that now the data about Aditi has ended and a new data is started. So we need to check all these consecutive blocks. Now for here Aman, we can create B2 as it started from B2. For Aryan, we can create B3 as it is stored in B3. Then Kiran, now Kiran, the information of Kiran started from B3 and also went to B4, right? Because there are two records where name was Kiran. So we need to store from where it started, B3, and when we are gonna search about the information Kiran, like someone writes the query of select star from student where name equals to Kiran, then what we'll do, we'll first look into our index file or index block. We'll scan this and find that the information of Kiran had started from block B3, and it doesn't, though we'll search B3. We see that Kiran was at the end and there was no new record, so we'll go for the B4 also, retrieve Kiran from here also, and then we'll see now there was new name Neha, so we'll stop our search here, and because we have found all the information about Kiran, all the students who had the name Kiran. So similarly for Neha we can store B4 and Riya we store the B5, and that's how our clustering indexing is created. As you can see, in the clustering index we create index for unique non-key field. Okay, this is again a sparse indexing. Why? Because as you can see, we are not creating index for each row. Instead, we are creating index for only each unique field or each unique value in the non-key field. So this is again a sparse indexing. So far we have talked about two types of indexing: primary indexing and clustering indexing. So as you can see, in both of these indexes, our data was sorted according to the column on which we are creating index. So in primary indexing, as you can see, our data was sorted according to the key field on which we are creating index, and our index was also sorted according to the key field, right? And in the clustering indexing, our data was sorted according to non-key field, as it was we create index on non-key field. And as you can see here, index file is also sorted according to non-key field. Now, so if our data is sorted, then we can create primary indexing. But what if our data is not sorted? So it is neither sorted on the key field or non-key field. Then how do we create index? So that's where another indexing technique called secondary indexing comes in. So how does secondary indexing works? In secondary indexing, there is no need for data to be sorted according to any row, either on any field on which we are trying to create the index. So if we are trying to create index on the key field, so it is not necessary for data to be sorted according to the key field. So for example, as you can see, so if we are trying to create index on the key field, so we call this as a secondary key indexing. So as you can see, your data is not sorted according to the key field. In this case, how do we create index which can help us retrieve fast retrieval in the database? So again, we'll take the same example. There are 5 blocks needed: B1, B2, B3, B4 and B5. And you can see that the data is not sorted in any manner, right? On the key field, data is not sorted. This is our key field. So in this case, how do we create index? So what happens in this case? Our index file stores information where exactly one roll number or one, because we know that key is unique, so we need to store the information key where exactly this roll number 1 is stored for in the index of roll number 1. So here index will store two things: roll number or the key field where about which this index is, and will store the block pointer in which block this is. And apart from that, since one block can have multiple records, will also store record number ki which record in that block this roll number is. So for example, roll number 1, where exactly it is stored? It is stored in block b2, and it is the second record of that block. So second record of the block. Similarly, where is roll number 2? It is stored in b1, and it is also second record of that block b1. Similarly, 3 is stored in b4, and it is first record of that block. 4 b5, and it is the first record of that block. Roll number 5 is stored in b1, and it is the first record of that block. 6, where is 6 stored? b4, and it is second record of that block. 7, where is 7 stored? b3, and it is first record of that block. 8, where is 8 stored? b5, and it is the first record of that block. 9 b2, and it is the first record of that block, as you can see. And 10 b3, and it is the second record of that. So as you can see, our index here, our index is storing 3 things. First, the key field for which this index is. Second, in which block this data is, and in that block which record number it is, for me to identify exact. So it stores these 3 information for one key value. So as you can see, what we are doing here, we are creating the index for each row. This for row 1, 2. So each row we are creating an index here. So this is known as a dense indexing, where we create index for each row. Now when we are trying to search for our data, we'll simply, for example, roll number 4 will access the index file. We'll see that at b5 this roll number 4 is stored. We'll go to the b5 and search for the this typo. Roll number 4 is b5, and 2, record 2 is there, and we'll check the record 2 of that. Okay, so that's how secondary indexing works. Here we did the indexing on the key field, that's why we call it secondary key indexing. If we would have done the indexing on the non-key field like name, then we would have called it as a secondary non-key indexing. So we'll take that, we'll do an example of that too. Okay, so secondary indexing can be dense also or sparse also, but primary or clustering indexing are usually sparse indexing. So now let's talk about, before we dive into that, someone might be thinking ki this became almost as big as our data file itself, though this we might be needed more than one block to store this entire index file. It is true, like if one block can store only 2 records, then but since we are storing less information here, so this one block might store more information. For example, this is one block all this are stored in one block, and all these records are stored in another block and another block. So to store the index itself, we are needed 3 blocks. So this is b6, b7 and b8. So in this case we need, so if our indexing file becomes too large, then we might do the indexing on this indexing itself, right? We can create another index which stores the pointers of these, and that is known as a multi-level indexing, where we create indexing of the index file itself. Okay, we'll talk about that later, but before that let's talk about the secondary indexing on non-key field and how does that work. So that is known as a secondary non-key indexing. In this we create a secondary index on non-key field. As you can see, data is not sorted. Again we have 5 blocks: b1, b2, b3, b4 and b5. Okay, now how does secondary non-key indexing works? Again we need to find key. We'll create an index for these non-key values. Now as you can see, how many unique non-key values are there? This is a unique one, this is a unique, and this. So we have 7 non-unique values, right? So what we'll do, we'll first store this information. For example, we'll create database blocks for each non-key field. So we'll create one database, one block, will reserve one block in the hard disk which will store information about RIA key. Where is this RIA? So in which blocks this RIA is stored? So RIA is stored only one single block, b1. So I can store key only b1 RIA is stored. For Aditi, we know that Aditi is stored in b1 and b2. So it is stored in b1 and b2. So what I will do in the secondary non-key indexing, for each unique value will use additional hard disk blocks and store where exactly that, in which hard disk blocks of the original database these values are stored. For Aditi we have created, then we can create same for Aryan. Where is Aryan stored? Only in b2. Then we can create same for Arav. Where is Arav stored? b3. And we can store again for Kiran. Where is that stored? b3 and b4. And we can store for the remaining ones Neha. Where is that stored? b4 and b5 too. And the last one Aman, that is stored only b5 only. So the first will use extra blocks to store where exactly each unique value is stored. So we needed extra blocks, so let's call this as a b6, b7, b8, b9, b10 and b11, b12. Now what we'll do, we'll simply create an index on for each unique value, and in index what we'll do, we'll store this pointer, this record point block pointer. Why? We can simply go to this block and find out key in which blocks exactly what their data is stored. So in this secondary non-key indexing, this is simply, we'll first create this, and now the index file, it will store the non-key field, so name and block number, block pointer. So for RIA, it will store the address of the block B6 where all the information about RIA is stored. For Aditi, it will store the address of B7. So whenever we want to search for Aditi, we'll first go to B7. We'll check the actual data about the Aditi is stored in two blocks, B1 and B2. So now we'll search B1 and B2. Okay. Similarly, if we want to search for Arav, then we will, where is Arav information stored? B9. So we'll first go to the B9, check for Arav, and then we'll, from there we can see that Arav's information is stored in B3. So we'll go and search the B3 and retrieve the information. So that's how secondary indexing, secondary non-key indexing works. So here you can see it's more of like multiple levels of index are created first to make it more compact, because if we would have done simply this, we needed to store for RIA, we need for example Aditi, we needed to store keep it is in the B, instead of B7 we needed to store B1 or B2. So to make it more compact, we reserved one block and stored all these key where RIA is Aditi is stored, and that address of that new block is stored in the index. Okay, so to summarize, there are four types of indexing. Okay, we have the primary indexing, we have the clustering indexing, we have the secondary key field indexing, and secondary non-key indexing. In primary, it is done on the key field and data is sorted according to key field, right? And it is an sparse indexing. Clustering is done on the non-key field, data is sorted again on non-key field, and it is also sparse indexing. In secondary indexing, secondary key indexing, we did the indexing on key field, data was not sorted, and it was dense indexing. Here second non-key field, data was not sorted, and it was technically sparse indexing. As you can see, indexing was only done on unique values, not each record or each row. Okay, so that's all there is to know about the indexing. Now in the next video lectures we'll talk about how to make it more efficient, because as you can see, let's suppose this is my index, right? Here we are doing the indexing. If you can primary indexing, as you can see, this is the index. Here we are saying ki indexing is fine, it improves our search, but here also one problem is ki we are searching linearly in the indexing. So let's suppose ki here this index file was not stored in just one block, but there were 3 blocks were needed to store the index file. This was block 1, 2 and 3. So these were the index file blocks, and that's perfectly okay because that can happen. So here, to search for one sorted row, for example 5, it was, let's suppose this data, this was stored in first block B1, this was stored in block 2 B2, and this was stored in block 3. So here if we want to check the roll where the roll number 5 is stored, we need to search in the index. So here again, as you can see, we need to first check B1 key, right? Key, is there 5 in this one and this one, and then we'll check if 5 is there, and from there we'll go to this field and store, check this. So again, the searching on the indexing is done in linear manner, right? Because we needed to check in all the blocks, and this can take this is time consuming. So to improve this search time on index, we can make search a bit faster in the index. We'll implement these index as a tree data structure, so and reduce our search time from linear of order n to order log n or log height of that, so that our search and indexing can become even faster, right? We'll try to use binary search technically on the index to make it faster. So in the next video we'll talk about how to store our index as a tree data structures, and we'll talk about 2 special trees, B tree and B plus trees. Okay, so let's stop here.